fifth chapter, Trigonometry. In this chapter, we talk about triangles, their sides and angles. Look at the first question. We are given a triangle ABC with angles 90 degree, 45 and 45 degree, and one side is given to be equal to 3 centimeter. Our question is, what are the length of other two sides? I have drawn one more triangle PQR with the same angle measures 45, 45 and 90 degree. You can call these two triangles to be isosceles right angled triangles. It is because one angle is 90 degree and the other two angles are equal. If two angles are equal, we know the triangle is an isosceles triangle and the sides opposite to equal angles are equal. Here, opposite to 45, you have 3 centimeter. So, we can say opposite to this 45 degree also, you will be getting 3 centimeter. So, in this triangle, we can say AC is equal to 3 centimeter. And what about the hypotenuse? BC is opposite to 90 degree. We call that to be the hypotenuse of this triangle. So, to get BC, we use Pythagoras Theorem. We know in a right angled triangle, hypotenuse square is equal to base square plus altitude square. So, I am going to write BC as root of base square, that is equal to 3 square plus altitude square, which is again is equal to 3 square. If you add root of 3 square plus 3 square, you get root 18. Now root 18 can be also written as 3 root 2 centimeter. Do you understand? Root 18. If you have doubt, I will explain. To get the value of root 18, we are factorizing the number 18 using prime numbers. You can divide by 2, you get 9. Again, you can divide it by 3, you get 3. So, 18 can be factorized as 2 into 3 into 3. 18 is equal to 2 into 3 into 3. Since you have a square root, we can take 1 3 outside the root. So, you will be getting 3 root 2 centimeter. So, you got the third side BC as 3 root 2 centimeter. Is it clear to you, children? Same way, let me find out PR and QR also. What is PR? PR will be equal to 5 centimeter. It is because sides opposite to equal angles are equal. Opposite to 45, you have 5. So, opposite to this 45 degree also, you get 5. So, you got PR is equal to 5 and QR. The hypotenuse is equal to root of base square plus altitude square. You get 5 square plus 5 square. That is equal to root 50. That can be factorized as 50 can be written as 5 into 5 into 2. 1 5 can be taken outside, so you get 5 root 2 centimeter as the third side. Is it clear? From this you can come to a conclusion that if the angle measures are 45, 45 and 90, sides are proportional to the numbers 1 is to root 2. If you get 3, you will get 3 root 2. If side is 5, you get 5 and 5 root 2. If side is 7 centimeter, what do you get? The other side will be also equal to 7 and hypotenuse is equal to 7 root 2. From this, you come to a conclusion that in a right angled triangle with angle measures 45, 45, 90. Sides are proportional to the numbers 1 is to root 2. The sides of any triangle of angles 45, 45, 90 are in the ratio 1 is to root 2. You should remember this. Okay, we are going to the next idea. Here we talk about a equilateral triangle. You know, in an equilateral triangle, all angles are 60 degree and all sides are equal. I took one side to be equal to 6 centimeter. So all three sides are 6 now. What we are doing here, from C, if you draw a perpendicular, you will be able to get a triangle like this. Okay, angle B is equal to 60 degree. Since we are drawing a perpendicular line, angle at D is equal to 90 degree. Therefore, the third angle will be equal to 30 degree. Do you understand, children? BCD is half of an equilateral triangle. Now, this side is equal to 6 centimeter. In an equilateral triangle, if you draw a perpendicular line, you know the base will be bisected into two equal parts. So, we can say BD to be equal to 3 centimeter. Now, we have to find out the length CD. Using Pythagoras Theorem, we can find out CD is equal to root of hypotenuse square minus base square. That is, you will get 6 square minus 3 square. That is equal to root of 36 minus 9. 36 minus 9 gives you root of 27. Now, 27 can be split into 3 into 9. Isn't it? 3 9s are 27. Now, root 9 is equal to 3. So, you will be able to write this as 3 root 3. From this, we got the length of CD to be equal to 3 root 3 centimeter. I have written the ratio of sides, children. BD is to CD is to BC is equal to 3 is to 3 root 3 is to 6. We can simplify this because all numbers are divisible by 3, isn't it? So, I will be able to write this as 1 is to root 3 is to 2. Now, let us change the measure and find out the ratio of sides. Okay. Now, instead of 6 centimeter, let us change the side to be equal to 8 centimeter. I took this side to be equal to 8 centimeter. So, you know, an equilateral triangle, a perpendicular drawn from one vertex bisects the base. So, you will be able to get BD to be equal to 4 centimeter. In the same problem, instead of 6 centimeter, I have changed the measure as 8. So, if this side is 8, I will be able to get BD to be equal to 4 centimeter because a perpendicular drawn in a equilateral triangle bisects the base. Here again, let us find out the measure of CD. You get CD is equal to root of hypotenuse square, that is 8 square, minus base square, that is 4 square, which is equal to root of 64 minus 16, which is equal to root of 14 minus 6 gives you 8, 5 minus 1 gives you 4. Now 48 can be split as 3 into 16. 3 16s are 48. Now what is the root of 16? It is equal to 4. So I can write this as 4 root 3 centimeter. Here again, let us write the ratio of sides. So if you write BD is to CD is to BC, you will get 4 is to 4 root 3 is to 8. Now here all numbers are divisible by 4. So if you divide by 4, you get 1 is to root 3 is to 2. From this, what did you understand, children? In any triangle with angle measures 30 degree, 60 degree and 90 degree, sides are proportional to the numbers 1 is to root 3 is to 2. We use these two ideas for doing problems in our first exercise. We will do the problems in first exercise in our next class. Thank you.